For a while now I've been wanting to build up another PC out of this load of spare parts I've got, purely for doing hard disk drive testing and checking, data recovery, imaging, that kind of thing. I used to use this old machine you can see here. Most of the time this was used just by having the cover off and just plugging stuff on the main board and having wires everywhere and Molex power extensions and all that kind of thing. I'd like to do something a bit more self-contained, and I'd like to have something a little bit more updated as well, because obviously as you can see by the case on this, this is quite an old system that's in here. I've got this ICDock hot swap bay which takes 3.5 and 2.5 inch drives. It can actually take a 3.5 and a 2.5 at the same time. So I'm going to base the new build probably on that. So that'll give me, obviously I can take out a CD-ROM drive from the case I'm going to use and put that in there. I won't be needing the CD-ROM drive because I've got another solution to that. Sometimes a CD-ROM drive is useful in these situations because you can boot your imaging software off the CD and you've got no system running. And I personally just prefer to do that because I know there's no operating system interference when I'm imaging a disk. So this old system here, we'll have a quick look inside. While we've got it here, we might as well. One thing I liked about this case is the fact that it's so small. It's nice and compact. It used to be used for testing and things. You can see there's quite a lot crammed in there. It's a micro ATX motherboard, and let's say this is an old one. I think this is a P4, so you've only got PCI slots and even an AGP in here. That's how old this one is. But it does have a couple of SATA connectors down here, which obviously is necessary. But again, these are only SATA 1, so it's not ideal, say for imaging SSDs or something like that. There's no real option to upgrade this because obviously it's only PCI. If it got PCI Express I could obviously put some cards on, but it's probably not really worth it with how old that this is. So instead of using this, I'm going to use a different system. So what I've got instead is this thing. It's a little bit bigger. Picked 3 of these up at my old job. They were all going to be thrown out, so it seemed a bit of a shame. They're not bad cases. A little bit wider than this case, but otherwise about the same sort of thing really. Just a micro ATX board that you can get in there. The power supply on this is a little bit easier to get. This one's slightly narrower and they're quite hard to get, and most of them have this little ballast transformer on them and it tends to buzz, which is one of the issues with this, why I stopped using it. It drives you up the wall, it's that noisy. So I'm going to open this up and we'll strip out what's in it, because I think it's also got an old board in that I think is due for scrap. So a little bit more up to date, but not a lot. Again, an AGP card. I don't think that's probably an old Pentium D or something in it, so not much cop really. So I'm going to strip all of this out and then we'll have a look at another board that might be suitable. Get a bit more light on that. So as you can see, that's pretty much emptied out now. So I've took the power supply out just to get it out of the way, and I can have a quick look at that as well. One thing I quite like about these is I've got this little fan grill on the front and a proper air inlet from the front. This sort of case generally doesn't have that. It tends to rely, you can see down inside here, you've got some holes along the bottom. A lot of these cases just tend to rely on that, and the fans in the power supply or any other fans that are mounted on the back here to draw the air out. And generally you can't get too much of any use in these small spaces at the back. So I think the fact that it's got that on the front is a really nice touch. You've just got the usual rubbish power reset, which I think also acts as a hard drive LED and USB ports and whatnot that we're not interested in. This old board, there was a load of this particular model, and as you can probably see, There's a lot of these capacitors are starting to bulge on the top, so these boards just generally seem to give out after a while. But yeah, so this is a really old board, it's not really of any use at all, so I'll probably just go on the scrap pile, unfortunately. May nick the heatsink off of it though, I might be pinching that. Now, the board I've got isn't exactly new either, but it's more up to date. It's just a socket 775 I think, but we've got a couple of PCI slots, so I can put a graphics card on here that will give me HDMI, VGA and DVI, which is handy to have, so I can hook this up to any old monitor that happens to be spare. And it's got about 4 gig of RAM on it as well, which is enough just to run a basic Windows installation and a bit of software to do imaging or data recovery for anything I want to do within Windows or even Linux system. And we've got SATA 2 sockets here. Again, obviously not super fast, but for what I'm going to use it for, it'll be quick enough. And there's always the possible option of adding another card if I want faster speeds. What I probably will do is put a card in to give me USB 3. One of the things I want to test is some of these Seagate external drives that I've bought, and I want to test these because the idea will be to rip the drives out of these casings and then use them in something else. But I want to check them first before I do that, because obviously that's going to invalidate any warranty. Now, one obvious issue with this is the heatsink and fan that's on here is absolutely massive, so this is probably where I'm either going to pinch the heatsink and fan off the other system, or see what else I've got that's low enough profile to fit inside that case. And obviously this is no good, this is going to have to come off. And this was one of those sort of custom fans for the heatsink originally, and they're always a pain because when the fans eventually wear out, you've got no fan for the heatsink because it's sort of been built for that heatsink. So as you can see on this one, I've actually managed to bodge a normal fan on by screwing through the back there, and then just a couple of cable ties around the framework there and there. Just through a couple of holes, that's about all I could really do with it. And then I've just screwed a grill on the front. Otherwise the whole thing's scrap, which is just ridiculous really. I don't know why they do it, why they don't just use standard fans. I think it might be a Core 2 of some point, sort. There's Core 2 Duo, 3.08 gigahertz, so 3 gigahertz, which will do for what the purpose of this machine is. So another thing with the different heat sinks and fans, one thing I really don't like about these particular ones is they have no strain or retaining plate on the back. Now the other board had one of these on the back, and the heatsink screws into these points here, and that gives the back some bracing. Now the problem with these, as you can probably see, is there's no bracing on the back. These just go straight through the board, and this is what happens. You get this bend occurring on the board, and sometimes if that's too much, what can happen is the socket separates from the board, and then the machine's basically dead. Use this Amiga expansion trapdoor against there and you'll see, you can see the bend on that. It's quite severe. Probably show up even more that way. So there's quite a gap there because of that. So although I want to use this heatsink, I'm going to have to find some way of perhaps bolting that to one of these, because I've got some of these spare, so the back of the board's actually properly supported, because these are just crap basically. These are easy to release, you just turn these these things around and then they'll pop up and out. Well, I'll say they're easy. If you can get your fingers in there, and that should in theory just pull off then. Like that. So yeah, unfortunately there's not really a lot here of any real use. Even the RAM probably not much use these days. So that will just go probably in the scrap boards box. Not sure what I'll do with the RAM. Probably just chuck it in the bag with all the other RAM. So as I say, I think what I'm going to try and do is mount this onto here using this plate rather than these plastic clips. So that means these are going to have to come out, and I'm going to have to try and find some bolts and washers that will stop the bolts falling through these holes on here, because they've got quite big holes. Obviously the bolts have got to fit into this thread. A lot of the time you get these special bolts with a spring on them, and the idea of that is that it puts tension on the board to hold the heatsink on, but there's a bit of give in it. You can just bolt it straight on, but you've got to be really careful not to over tighten it. Now whether I'll do that or not I don't know at this stage. So as I was saying, I want to try and probably use this heatsink or a similar one, because it's got a much lower profile. I do need to check this will fit in the case. Now obviously you've got these plastic locking mechanism on these four corners. To remove these plastic pegs, normally when they're locked in on the processor, when it's on the board, they're in this position here, and you can see that white plastic bit's pushed into the black and there's not really much movement available. Now you see on the top here there's a bit of an arrow, and that arrow that shows you the way to turn it to release it. So if you then turn it anti-clockwise, you can then pull this up, and that's what releases the processor. There's a little black peg that goes in here that spreads these out when it's locked in on the board, and that stops this pulling out. As soon as you do that, these can be squeezed together and it can be pulled through the hole in the board. So that'll be these holes here. Now to remove these, I found the easiest solution is to then force this round even further than it's supposed to go by about another quarter of a turn, and it will ride up on a bit of a lip on this white plastic. You keep pulling them as you do it, and you see that's just come off then. And that's the way I found that's easiest to get rid of them. And then here, this bit's got like a little bit of a nub on it, and you just need to basically work that out through the hole. That's not very clear, but you see there's a little bit of a slit in that, and there's a bit of a plastic nub that sticks out on this bit here. So you just got to work that through that hole there, and that's all of them out of that now. So what I then need is to find some washers or bolts or something to attach this down using one of these. Now I could use these off the other heatsink, so that might be an option. So I've had a look through the spare parts I've got, and I've found another one of these which is even shallower than the one that was in the other PC. And you can see that's still significantly shallower than this tower heatsink. But I'm not going to use these because I've managed to find this one. Not entirely sure what this came off of, but it's a bit taller than the others. But this will, I think, still fit inside the case that I'm using. And because this casing, because this has got this grill on the top, that will be near enough in alignment with this fan, so there'll be plenty of airflow. So I'm going to go for that, as you'll hopefully be able to see. It's quite close to where the top of the case would be, but this casing has actually got sort of a vent hole near the processor anyway, so I don't think we're going to have too much of an obstruction for airflow there. And the same at the side as well, we've got some vents here, so I think that's probably going to be the ideal choice for this. And I found some more of these metal back plates I've got plenty of those spare, and I've also ordered some of these bolts. If you want to find these, if you go onto eBay and just search for heatsink bolts, you'll find these are sold usually in sets of 4. Obviously the usual case, they're a lot cheaper from China. And if you're interested in some of these metal backplates, just search for heatsink backplate and you should find them. What I have found helps is if you put the number for the processor in, or the processor socket. So in the case of this Core 2 Duo, if you put in heatsink backplate 775, because it's a socket 775 chip, then you'll get loads of these sort of things coming up. I've also been looking at the main board in terms of what I want to connect up. As you can see on here, we've got 4 SATA 2 sockets. Now that's probably not going to be enough, because I've got the IC dock, which will need 2 all for itself. I'm going to need 1 for the internal SSD to boot the system. I also want to have another hard drive in the machine, a mechanical hard drive, just as a storage dumping ground to copy any data to or any images. And that makes 4. But I also want to be able to connect up one of these eSATA ports. Doesn't have to be the both, just one will be fine. So that's obviously going to be 5. So what I'm probably going to have to do is make use of the IDE port, and I may just put the system SSD on that, because it's not going to be anything fantastic. It's just for booting Windows or Linux off of, so it won't need to be anything really quick. I could even install the OSs on the same drive as the data drive that I'm going to put in here, but I'd prefer to have them separate. It's just nice to keep, I think it's nice to keep the data on a separate disk where you can. Now the reason I want to be able to have an extra eSATA port on this system is so that I can attach and plug in other drives without using the IC dock. So I can just plug something in either straight out the back of the machine or the front, depending on how I mount this. And I can use one of these cables. This is basically an eSATA to SATA cable, except this is actually an eSATA P. So you get the 5 volts down the middle, which you can actually also use these ports as USB ports, USB 2 I think, which is why you've got the USB header on here. So that will take 2 USB ports, so you can then use these as either USB 2 eSATA or eSATA P. And there's actually 2 versions of eSATA P. The first version will basically draw 5 volts from the USB port, so your 5 volts power will come out here as it would, so you obviously can plug in a USB device and get that powered. But these eSATA P ports actually pick up the 5 volts that would be for the USB, and then they use that to power the SATA power connector here. So you can connect up a laptop hard drive to this cable, and you've got your data and your power in one, so you don't need a separate external power supply. But these have also got this extra little contact on the sides, and that's where it picks up the 12 volts from. Again, in this socket here there's a 12 volt, and that's why we've got this power socket here. So that's used again just to pick up to get the 12 volts from your internal power supply through this socket and out here. Well, and what that actually means is you can plug in a full-size 3.5-inch desktop hard drive to this without the need for an external power supply, which could be quite useful. I'm not entirely sure how this is wired up. That's something I'm going to have to look at. So I don't know if the 5 volt is fed from the USB to these eSATA ports, or if it's using the 5 volt from the USB connector. I'm not entirely sure, so that's something I'm going to have to look into and see how that's all connected up. But I'll probably add this on at a later stage. So let's get this thing together. That heat sink's nice and solid on there. And I've got a USB 3 card here, and it's got a little bracket so I can convert it to a half height card. Looks like that's probably got bent in the post like everything does. I've purposely left the screws on this board a bit loose because I've found the best thing to do to get it lined up is actually get a card in. You can make sure that there's not going to be any problems then. Tighten the board down. Card's in the way now. The nice thing about this little card is it's got the two USB ports on the back, but it's also got an internal header, so I could run two additional USB 3 ports perhaps somewhere to the front of the casing if I wanted to. And we've also got a power connector, so just a Molex, which is probably better for this particular system because I'll have more Molex free than SATA. I have to admit I'm not too happy with the way that's sitting in there, sitting a bit high, so it goes in there, but then as soon as I press on that it lifts it. Yeah, the board does appear to be a little bit low in the case. Now one thing I could do is undo these, just try and push this bracket. There's a bit of movement there, you can push it that way and that will then mean the card will sit slightly lower, but it won't be much, but it might make a little bit of a difference. You see that pushes down quite a bit, but as soon as that's tightened and levelled it really does pull it out quite a way, so that's not really very good at all, that. So I really wasn't happy with how this card was sitting on the motherboard. So what you can see I've done here is file these holes for the bolts slightly larger. So what that means is that the card can now sit slightly lower on the bracket, although I am limited by how far down I can go by the ports on the back here. So I'll try that first, and I've also found some screws that are slightly bigger head on them but still with a short thread, so I'm going to use those instead. Just slacken them off a little bit. I think what I'll do is put the card in and try and get it in a good position and then see if I can tighten the screws up. And I'll just tighten these up now. And the ports have just gone into those holes a little bit, so you can see there it's moved along quite a bit. It's also slightly angled, so that sits in quite nicely now. It's at a very slight angle, but once that's been bolted down that's much better. The PCI edge connector's not popping out the socket now. So I picked up some of these 5450 graphics cards cheap on eBay. These are quite nice because they don't require any extra power and they're also passively cooled. I've got this one in a low profile bracket. There's also a VGA bracket for it as well, which just plugs in on the socket there. Annoyingly, this has come, as you can see, with the hex nuts missing and a screw in that one there. And even more annoyingly, although I've got 3 ice cream tubs filled with film canisters with varying screws and things, and I actually can't find these, so I'm just going to pinch them off one of these bigger cards for now. So the bracket for this is a little bit on the flimsy side. You can see it's a bit buckled and bent. So I've got a load of other ones here. I've got about 500 elastic bands around them. Or maybe it's just one really long one. Either way, it's annoying. And these are much better quality. They're thicker steel, and I've got this little bracing bit that's bent over here, so they're much more solid. So I'm going to just use one of those instead. Now this thing's also keyed, so there's a pin missing on that top right side or top right corner. And the same on this connector, there's a pin that's filled in, so that has to go on a particular way around, which pretty much determines which way that this thing can go. You can see where the cable was bent previously. Let's try not to over tighten this. Adding the missing bolt onto here. So that's that pretty much sorted. I think that VGA cable is a little bit tight because the position of the VGA socket's a bit lower on this bracket to what it was on that one. So obviously that makes a little bit of a difference, but no, we should still be able to get this in. If it's a problem, there's always the option of rewiring one of these ribbon cables on that's a bit longer. I've got plenty of cable that could be used to do that. So that's locked in place in the slot. Should be okay. And what I might do is put another card in here. Possibly got a SCSI card spare that I'm not really going to do anything else with, so it makes sense to just throw it in here, and that will then help keep this bracket stable as well. There's a variety of different cards and things here. Most of these are too big though, unfortunately. And looks like the card I had in mind is going to be a bit too big. Unfortunately. So for the time being, I'm just going to tighten the graphics card down, and also this bracket. I'm just going to bend this a little this way because it's not quite as it should be. Yeah, so unfortunately the cards on this particular case don't get an option to sort of lock into any holes in the metalwork underneath, so there's a bit of potential movement there. Because this doesn't have a slot, it can move. Now what I could do is just cram a bit of plastic or something down in there to stop that, which I may do at some point. For the time being, it's good enough. So I've still got all these front panel leads to connect up. I don't normally connect all of them if they're not needed, so this audio one for example is probably not going to be needed, but I am going to connect it up just to get it out of the way. The actual socket for this is down here, it's this green one. There's two plugs on this, one's marked HD audio, the other one AC97. I think this is an older style where on the board you would have to actually have some of the pins on the connector jumpered if you weren't using the front panel. If you didn't do that, then you wouldn't get audio out the back, so I think that's what this is. I think it shorts the pins, because you can see. So those two pins are connected together with the blue wire, and then there's these two that are connected together with the green wire just to short them out, and they're probably the left and the right audio. And then you'll have a ground, and then there's usually a plus and minus for the microphone. But we're not going to use that. We're going to use this one, and these are also keyed. So I'm just going to cable tie this out of the way on here and then plug that in just to keep it out of the way. And what I could do is cable tie this onto the back of the casing at some point if I wanted to. And we'll leave that for now. We'll see what other wires have got to be ran first. And here we've got a connector for the front fan. There's quite a bit of slap wire on this still, so it should be enough to get that plugged in down here. And the system fan connector. And then we've got, well, it's basically two USBs here, and that will go into either of these two yellow ports. I shall plug it into this first one for the time being, just to get it out of the way. It just tidies up around there, and obviously I want to try and keep this fan clear of any wires. And then we've got the three standard hard drive, power and whatnot front panel cables. And while I'm also at it, another thing I'm going to do, because I've got plenty of these spare, I bought a whole load many years ago, never used them, I'm going to just shove that on there. So if I am running this with the lid off, I'm not going to get my fingers in it, because it does hurt sometimes. I've managed to find some screws in these little canisters. So one of the other things we're going to need to do is get this dock system in. I will actually do a proper review on this separate at some point when I've had some time to use it and see what I think of it. But for now I'm just going to get this in and get on with it. Another thing I'm going to actually do while I remember is to take this annoying metal bit off at the back. It's to put a lock through. It's pretty pathetic, but I find it gets in the way. Even when you're just trying to slide the lid on at times, it's quite annoying. Front should then come off. Yeah, it's just a bit of a grip on the midsection. No easy way to get at that to release it. There is also a lock here that sticks out, but I'm going to leave that because taking that off is probably going to leave a bit big of a hole, I would think. I think that's going to... There's a shielded section here. I think this is where the hard drive goes, because then you can leave this top bit free, which can then be used for something front panel related. So I may actually be needing to put something in here, depending on how everything else gets mounted at some point in the future. So I'm going to try and leave that free and mount the hard drive on the lower of the positions on this rack. Well, that's annoying. It seems that these bits here are catching on the top side of the casing, which could be a problem. That was a bit of a painful manoeuvre, and it's catching on the sides now as well. So this is very much on the limit of this size restriction for a 5 1/4 inch drive bay. I think we should be aligned somewhere around there. I'll just get those in on this side as well. And power supply. These supplies have this extra lug down here, and you just put a screw in there and it just anchors the end, which is quite good because it stops it flapping around and straining the screw threads on the back. The bay only needs a single power connector for the SATA power into this, and then there's 2 SATA data connectors. You can see there's the power, and there's the 2 SATA data connectors, one for the 3.5 and one for the 2.5 drive. I've got the usual 4-pin CPU power connector, which needs to go all the way over here, and this will need to go down onto here. That's a 24-pin, not a 20. So you see this additional 4 pins previously been cable tied out of the way. I assume the previous board didn't have the extra 4 pins, the drive, so that's nice and neatly out of the way. So we've got a Molex, a SATA, and I'm not quite sure what they're actually called, floppy drive cable. And then, oh, we've got a Molex to SATA adapter there, so we've just got 2 Molex on that one. So not a lot of power connectivity. Yeah, so I can either run this end of this long cable to there, or double this up and run them both to there, and then this single one can then run to wherever it needs to. I think I'll do it that way because it just seems to keep the cabling a bit neater. It's a bit tight, but that's actually keeping it neat and tidy. And we've got a SATA power connector here that we can use for this caddy or rack, hot swap rack. And then the 3.5 inch floppy cable is probably going to be used to power a an IDE to SATA adapter that will go straight in there, so that puts this in the right place where it needs to be, and again it leaves us with a free Molex connector in this vicinity that we can use for whatever else we need. And I'll probably somehow tie all this lot together just so that it's neat and solid and doesn't move about. So I've found a part drawer has got a whole load of these different IDE to SATA adapters that I bought over a period of time. Some of these are really not very good. In fact, most of them are a bit cheap and nasty, to be honest. And we'll just have to try one or two and see what we get. Some of these aren't going to be usable because these, for instance, the notch is there, so that will have to go that way. So the power connector is obviously going to get in the way of that socket. You see the keys there, so they're not really an option. None of those are. So it's more likely going to have to be one of these sort here. There's two sorts here. These are two-way, so you can either do IDE to SATA or SATA to IDE, and I think they both do that. So this one's got a switch to pick the mode that it operates in, and this one's just got the two ports, and you just, depending on which port you plug into, is what mode it operates in. And as you can see, you've got a power connector here, a floppy drive power connector, so you need to plug into that to power the board, and then that will then convert your IDE to your SATA, or vice versa. So that would just go in like that. Then we've got obviously this spare floppy drive power connector that I was mentioning earlier. That would go in there, and then that would give us an additional SATA port, which I could use to power the SSD to boot the system. As I say, I don't really need a super fast boot drive. It's not so much the transfer rate for booting, but more the access time of an SSD that makes the biggest difference compared to a mechanical disk anyway. Now I can already see a potential issue with this, because the SATA port's there and the other two SATA ports for this are here, so there could be a clash for physical space there. So I'm just going to have to see how that goes, and maybe I'll be able to use a right angle on one of these. So I've been taking another look at this IDE SATA adapter, and it is this end port here that's for the SATA hard drive, and this one's for a SATA host. So it is the port that is unfortunately underneath the other sockets on this hot swap rack that I need to use. So I now need to check and see if that's going to get in the way. Now I've got a selection of SATA cables to choose from, and I've managed to find quite a nice short one here with a right angle on it, so that should mean I can connect that on that end one there. I'll be able to plug in these ports above that and it not get in the way. At least if it was the right way around, I'd be able to do that. So yeah, that's about as close as it could get. So that gives me a point to plug in whatever drive I'm going to use now. It's a bit stiff, that cable being so short. This is the SSD I'm using. It's just an old cheapo. This is a 32 gig. Not sure if that's going to be big enough or not really, because I want to get Windows 7 and a Linux install on. Although we're not installing like masses of updates and Office and God knows what else, so that should be big enough. The only other issue I've got with this is figuring out how to mount it, because it doesn't really have any sort of standardised mounting positions, unless these holes are standardised for a particular purpose. But in terms of mounting in this case, it's a bit of a nuisance really. I may actually need to find a longer cable for this. I was thinking if I could attach a bracket over here, I could perhaps mount it here somewhere. I'm not entirely sure. There's space underneath this hot swap rack, but I'm probably going to try and get a fan under there, because one of the problems with these racks is the hard drives can get quite toasty, especially when the lid's on something like this. It's all going to be very enclosed, so I need to try and force some airflow around in here. So that space is kind of taken really, unless I can find somewhere else to attach this out of the way. An even shorter SATA cable, and it just shows it with these angled ones. They're right angled, but they can be different orientations. So they both would be plugged in the socket in the same way, but the cable's coming out the top in one case and the bottom in the other case. So at the moment I just really want to get something up and running and try this and see if it's going to work, because there's a few things I don't know. I don't know if these onboard SATA ports are going to support hot swapping, for instance. I don't know if this is going to be any good, so I just want to get something wired up that I can run and get an installation on and give it a try. And I'm just going to use the anti-static bag for that for the time being, just to shove that in there and mount that temporarily. I've also been looking at this little silicon image, I think it's silicon image, yeah, silicon image SATA bracket or SATA adapter. So just an old PCI one. Sadly, this one was picked up from Maplin for about £2.50, £3 fully packaged when they were shutting down. So I've found if I take the bracket off, if I put some plastic on the back, some insulating plastic, I could actually squeeze that in down here in this other PCI slot, and that will then give me an additional, well, probably not that one because of accessibility, but it'll give me at least one additional SATA port. Now, I might not be able to use this from, say, some boot up imaging software. It depends whether it will detect this chipset or not, but certainly in Windows or Linux I should be able to use this extra port. So what I think I'm going to do is utilise this bracket, as I've said, but somehow attach it to the front of the case, and then I'll have one of these ports on one of the onboard connectors, and then the other one I think I'll put to this card mounted in here, and that gives me a little bit of flexibility and some options then. I have had occasions where sometimes certain drives just won't, they refuse to allow the system to boot if they're on the onboard connectors, so it would be useful to have one that's connected to a card in a situation like that. Then I've got that option. So I'm also going to order a USB 3 2-port header so I can connect that to this onboard card and then run that through to the front, so I'll have 2 USB 3 ports on the front. I think on a machine like this where you want to do testing, you want everything accessible from the front. You don't want to have to keep messing around, going to the back of the machine to plug things in. Originally, when I was thinking of doing this machine, I bought bits like this eSATA bracket, and it's a low profile one, so I was going to put things all on the back, but it's just too much hassle when you're messing around, especially if you're trying to do data recovery. The last thing you want is any more hassle than you've already got. So fortunately, I've got quite a few of these nice short SATA cables. They've actually got numbers on because these are originally for a RAID card, I believe. So get these in place and get a couple of them hooked up down here. So I think I'm going to put the rack on the last 2 ports of the SATA controller, and luckily these seem to fit around here quite nicely. I think I might put them the other way around. Cable placement always makes a difference in terms of nothing, because that, and again these cables, they're orientated the opposite way. Why? Okay, so it's actually this, one of the ports is one way and the other port is the other way. That's bloody irritating, because that means I'm going to have a twist in one of the cables. Why they've done that, I don't know. I'm trying to avoid having twists in the cable. So they'll go like that. This card should be okay there, and once all this has been cable tied together, all the wires will help hold each other in place. This is probably going to have to go somewhere else. It's obviously going to be blocking airflow and whatnot here. So I've just found this box. This is all bits that were to be used possibly with the other PC, the original beige one that I showed at the start. And this was again all, well, as you can see here, this was going to be to do with the test PC. And I found a bit of paper here with some notes on, and the date on that is 2013, so a lot of this stuff should have been, I don't know what's been happening with it. More of these brackets. So I think I'm just going to probably go through all this and box it up and put it away. And I found this little wiring loom thing that I made up, and this was originally to connect a Molex power with a pass-through, well that's the connection, that's the pass-through, to a SATA power connector, so you could plug a SATA hard drive in. And then there's this switch which was made out of an old serial port and a toggle switch, And the idea of that was you can mount that in a DB9 connector, either on the back of an old PC or a bracket like this, and that gives you a toggleable switch so you can power a hard drive on or off. This might actually be useful on here, depending on whether or not I use this extra bracket at the back here. I could actually mount that in here and use this to power on or off the hard drive that I'm going to put in here, because the imaging drive I'm going to put in here, it would be nice to be able to disconnect it at times if it's not needed. The only thing is, it may be better to have a switch like this on the front again, so I'm not going to mess around at the back of the machine, the back of the PC. So the other thing I'm going to use with this is one of these. It's a little external hard drive caddy with a bit of a difference. I've not actually used this yet, and it's got its own little screen built in and some buttons on the side. And what you can do is fit a hard drive to this as you would a normal external hard drive, but this can then appear as a virtual CD-ROM drive, a virtual USB CD-ROM drive or DVD-ROM drive, and you can actually boot ISO images off the hard disk as if they were a CD. And this is really useful for booting imaging disks, where if you want to boot a disk without the operating system loaded, or even to boot a Windows installation CD. Obviously most people use USB sticks now, so in some ways this is perhaps not so useful. So I thought, no, I'd give that a go, and we'll use that with this. And again, this is something I'm going to do a separate review on when I've had a chance to use it. It's probably something that most people don't even know exists. I thought it was quite an interesting little gadget. It's an IODD2531. Not sure who makes it. IODD Co Limited. So this isn't really finished yet, but it's at a point now where I can get Windows installed and some hard drive testing software and start testing some of the disks. I really need to get them going so I can get on with the next thing that I'm trying to do. This room's a bit of a mess at the minute as well, as you can see. Just tipped everything out trying to find what I need. So I'm going to have a tidy up, give this a go, and then I'll probably do a part 2 on this at a later date. And obviously also I'm going to do some videos on the hot swap rack and this, wherever it's gone, this virtual CD-ROM DVD bootable hard disk caddy menagerie thing. So that's it for now. Nearly forgot.